Hello everyone, welcome to another video. We're looking now that we have had this really long introduction into trigonometry once again, we're going to go back and revise some ideas we did in the previous year's content. Now, once again, I've included our trusty friend, this trigonometry table that we used in the previous couple of videos. Now, you don't need to use this, of course. You can use your calculator, that's what it's there for, but I'm just going to work through this just to keep on brand with what we've been doing up until now. So we are looking in this video at just doing the SOHCAHTOA trigonometry we've been doing up until now. And I'm going to do this through the lens of understanding the similar triangles that we talked about in the previous video, and how no matter what proportion we have of sides and angles, we can always locate this on a particular table. And this is essentially what your calculator is doing as you go through things like this. Now, I've included a couple of questions that we're going to go through today, and like we've done before, we're going to first just identify all the sides we have. So here we're looking from the perspective of the angle 27 degrees. This is going to be my opposite, this is going to be my adjacent, and this is going to be my hypotenuse. So the two ones that I'm given are an adjacent and a hypotenuse. So from the perspective of this angle, I am looking for, if we use our SOHCAHTOA, I am looking for this one over here, because I have an adjacent and a hypotenuse. So the particular ratio I'm looking at is going to be cos, from the perspective of the angle 27 degrees. And this thing always equals to my adjacent over my hypotenuse. Adjacent over my hypotenuse. So if we go back to our trig table, I have cos of 27 degrees. Now, like I said, you can just pop this straight into your calculator, it doesn't matter. But I have cos of 27 degrees, so I have this value. This is the ratio linking the adjacent over the hypotenuse. I have cos of 27, that's 0.8910. So instead of this cos of 27 degrees, we can write 0.8910. Like I said, in your calculator, this is what it's doing anyway. Now this thing is equal to the ratio of the adjacent over the hypotenuse. So for that, I'm going to put in place of the adjacent here, my x, and in place of the hypotenuse, I'm going to put 11. So if my angle is 27 degrees, no matter how big or small my right angle triangle gets, in terms of scaled up or down, so if I keep this same angle, but I have a smaller right angle triangle like this one, or like this one here, just to really clarify this, I'm going to draw these in. So we can have this one here, we can have this one here, a smaller one, and an even smaller one, I can have this one here. So long as the angle is 27 degrees, it's always going to be, the ratio is always going to be 0.8910. So no matter how big my sides get, my x or my 11, if this was something bigger or smaller, I can always use this trig ratio here. Now I'm doing the same things we did before, but I'm just going through this a little bit slower and using the foundations that we built in the previous two videos. But for those of you who just want to know how this stuff works, we're doing that anyway, or you're concerned with how we solve the questions, we're working through that as well. So now that we have x on the numerator, it's getting divided by 11 here. So this is an equation. So we can get x on its own by multiplying this side by 11. That's going to clear the denominator, and what we do to one side, we do to the other side. So on the left-hand side, I can either write it as 11 times cos of 27 degrees, or 11 times this rounded ratio here. But once I do that, that gives me x equals to, I'll write it, you can write it both ways, but I'll write it as 11 cos 27. Let's just say I haven't done it like that as well. And as I said before, you don't have to do this step. This is just me reintroducing this type of table in for us to work through. Okay, and now that I have that, I'm just substituting in the left side. I'm just popping it into my calculator, and that's going to give me 9.80 centimeters to 2 decimal places. So we're doing it in the same way we did last year. I'm just giving you a different way to think about these things. Okay, so now that we have a slightly different angle here, we can here is where it's beneficial to just use our calculators because they're programmed for something like this. But here we have, with our angle, you may notice an added thing here. So we have this, not just our degrees, but we have something that makes it more accurate, this thing here. Now this means 40 minutes. So angles are measured in degrees, minutes, and seconds. So we have degrees, which is that. We have minutes, which is one of these. And we have seconds, which is this thing here. Now you have a button if you have a scientific calculator that looks like this. And this is what you're going to use when you start working through these questions on your own. You have something like this, and then you will have this thing here. This just means degrees, minutes, and seconds. So what we're going to do for this one, we're using a slightly more specific unit of measurement. So if we take, for example, a ruler, it could be meters, but it could have these little centimeter markings as well. It just gives it an added level of accuracy. That's what this thing essentially does. So we have that 1 degree is 60 minutes. This is just our unit conversions here as well. And 1 minute, we know that from before, is 60 seconds. We're going to talk about this idea a lot more in the later videos when we talk about finding angles. But in order to solve this now, we're going to go the same way about doing these questions. So we want to identify first all of the sides that are present here. So I have my angle. The side opposite it is this one. The side adjacent or next to it is this side x. And our hypotenuse is always the same. Okay, so the two ones that have information associated with them are my opposite and my adjacent. So using my SOHCAHTOA, I'm looking at tan. Tan links our opposite to our adjacent. So I'm going to set out my working out. So I'm going to say that the tan of my angle 53 minutes 40 seconds equals to my opposite, which is 71.3, over my adjacent, which is x. Okay, cool. So we'll just leave this as it is now, and I'll show you how you'd actually do this with a calculator later on. But now we essentially just want to make x the subject of the equation. We want to get it on its own. Now it's not really helpful to us on the denominator here, so let's bring it over to the other side. So we're going to multiply both sides by x. That gets rid of our denominator here. And this leaves us with x times tan of 53 degrees 40 minutes equals to 71.3. And now I can quite simply isolate x by just dividing both sides by this guy here. So that's going to leave us with x on its own on the left-hand side. So 53 degrees 40. So this all cancels out, and I divided this side by that thing. Okay, now finally I get left with x equals to 71.3 over tan of 53 degrees 40 minutes. And as you put this into your calculator, as you write this in, so you'll put 71.3 on your scientific calculator on the numerator, and as you do the bottom part, you're going to first click your tan button, and as you put in the numbers, so you're going to put in 53, and first, once we do that, we're going to click this button over here. I don't know if your calculator has the same one, but it should be written like this on all of the calculators. So we're going to put this in there, and you'll see on your calculator it will, so you click 53 and you press that button, it'll come up with this little square up the top. So that just tells you that you're doing this in degrees. And then you put in your next one, pressing that same button, that's going to give you your next unit, which is going to be minutes. So it's just essentially slightly more accuracy there. So once you put in your 40, you press that same button and you'll see, whoops, you'll see another little square pop up here. And we close the bracket as well. And once you do that in your calculator, that's going to give you 52.44 centimeters, once again to 2 decimal places. Now, obviously we've come a long way since using these tables here. I just thought I'd introduce it here because based on the last couple of videos, it gives us an idea of exactly what's happening behind the scenes. What's our calculator actually doing when we look at trigonometry? So obviously when we get to questions like this, where we have degrees, minutes, and seconds, we have an angle to some higher level of accuracy, we're going to obviously start using our calculators. And we do these by just laying out what our sides are, seeing which sides we're given, identifying the trig ratio based on the perspective of that angle, and then we set up our ratio or fraction on the right hand side and essentially solve for the unknown. But that's all we have on finding angles. This is revision from what we did previously, so we will look at finding angles and then some of the newer content that comes up in year 10 in the later videos. But thank you so much for joining me, and I'll see you next time.